first lightning talk tonight, or rather talk as it were, is Jeroen, who's going to be speaking to us about the phantom builder pattern. So please join me in welcoming Jeroen. Thank you, Jeroen.
All right, so I'm going to talk to you about the phantom builder pattern, or rather the Extensible records phantom builder pattern, which is a mouthful. It's rather a complex topic, so I'm going to split it into 3 parts. First going to talk about the builder pattern, then I'm going to talk about the phantom builder pattern, then the Extensible records phantom builder pattern. So what is the builder pattern? It is a pattern for creating configurable elements, view elements or whatever. So let's say we want to create a button, which is going to be our example for this entire presentation. And a button, you can configure it in many different ways. So what you might want to do is to do something like this. So you create a new button, so with some defaults, with the text submit, with the primary style, and with this message that triggers when you click on it, and transform that to HTML so that you can view it. You can use it in your view. So this is kind of how you use and read the builder pattern, or at least that's how I do it. What you might be used to more is the HTML pattern, which Elm/HTML uses. So that is the one on the bottom. So you give it a list of attributes, and it's basically the same thing as a build pattern. They're really equivalent. You can do the same thing for both. I do tend to prefer the builder pattern because the functions that you apply to it, the attributes in a way, they compose better because they're just functions, and we can compose functions. And also, it is easy to transform to use the phantom build pattern, which we're going to talk about. How a builder pattern looks in the implementation is like this. So you define a module button, you define the type, you define how you create it. Then you have a list of builder functions, or with functions, as they're often called, to modify the defaults, and then a way to transform it to whatever you need to use, to whatever to your view function. So here you have your type with all the data that it needs to, and then you have the builder functions. They take their data, they take the button, and they return a different button, which is the same button but with the changed properties. All right. So the problem with both the build pattern and the list pattern, or the HTML pattern, is that you can have unwanted combinations. So let's imagine that I don't want my buttons to be both be disabled and have an unclick handler, which it is kind of weird. I'm pretty sure, but I'm not entirely sure, that if you have this set up with the regular Elm HTML, then when you click on it, it does trigger, but it might be wrong here. So yeah, this is what we want to forbid, and this is what we're going to work on. So before we do that, we're going to need to talk about type variables. So type variables are arguments to types. So for instance, the maybe type defines a structure. So it's going to be either just with some data or nothing. And the data that it contains is defined by the type variable. So the type defines the structure, and the type variable the data. So here you have a name which is a maybe string. So it's a maybe with this structure that contains a string, and an maybe int contains an integer. Same structure, different data. And then you have phantom types. They are type variables that are not used in any of the constructors of the type. So for instance, one common example is currency. So let's imagine you have dollars, which is a currency of dollar, and euros, which is a currency of euro. They have the same structure because they're both currency of ints, and they have the same data. They just contain an int, but they are not the same type. And that's why when you try to compare them, for instance, or add them together, the compiler will tell you by giving you an error. So phantom types are useful to differentiate data that are similar, have the same structure and the same data, but that you don't want to mix and match. So for a button type, if we don't want our buttons to be, if we want to differentiate our unclick handlers and our buttons with an unclick and our buttons that are disabled, since they have the same structure and the same data, there's no way to differentiate them. But what we can do is add a phantom type. So that's just what we're going to do. We're going to add a new type variable inside button, which you won't see anywhere in the data that it contains. I called it constraints, but you can give it something shorter if you want. And we're going to change the module this way. So we're going to define a new type that is only going to be used for the type variable, which we call not disabled or clickable. We are going to have the opposite later. So I'm sorry for the very long name. I'm not inspired for those things. So when you create a new button, it's going to be a button in the not disabled or clickable state. And the implementation is going to be exactly like before, like for a regular build pattern. And then we are going to define a new custom type, which is disabled or clickable, so the opposite of before. By the way, this I named constructed the same way as the type by convention, and I add the never just so that I'm sure that this type never gets created, because I only want to see it in the type variables. So, and then we're going to change with disabled and with unclick in the same way. With disabled is now going to take a button in the state not disabled or clickable, and it's going to return a button in the state disabled or clickable. Same thing with unclick. And their implementation are going to be the exact same as before. And what we basically made is a state machine. So we start with a new button that is in the state not disabled or clickable. And then whenever we call with disabled or with unclick, we get to the disabled or clickable state. And that is actually sufficient to solve a problem. Because when you call with disabled on a button that has an unclick handler, you don't get what is required by with disabled. With disabled requires a button that is not disabled or clickable, but it gets a button that is disabled or clickable because that's what with unclick changed it to. Does that make sense until now for everyone?
Perfect.
All right. So what is going to be our constraint for to-HTML, our function to transform it to HTML? So we have two choices. Either we say I need a button that is disabled or clickable, in which case you force the user to call with disabled or with unclick. So you can only get from this state to the HTML. Or you say, I don't care about any constraints, and you can call it from anywhere. So you don't need to call with disabled or with unclick. Then you get an unresponsive or uninteractive button. So I would tend to go with the form one. But the choice is yours. So now let's get into a new problem. The text is missing. So if I want to create a button that does not have any text, that is currently possible. And that doesn't really make sense. So let's make that impossible. So a common solution, and the one that you would use for the builder pattern, is to move the mandatory arguments to the init or the new function. So you would have button.new text equals click me, for instance. That is very much possible, but it does have some drawbacks. So for instance, if you want a button with only an icon and you made the text mandatory, then you need to create a button with some dummy text, then remove the text, then add the icon, and then use it however you want. What you can also do, there are plenty of ways to get around this. You can have button.new with text, button.new with icon. You could have button.new with the arguments that is a custom type, that is either text or an icon or both, but then you need to create a custom type. And in all those cases, you need the text to be defined at the beginning. That means that you cannot create a generic button where the only thing that needs to be set is the text. So you can't say, hey, here's my button schema, please give me the text. No, you need to have the text at the beginning. So what I propose is to use the phantom builder pattern. So we're going to have two states. So no text or icon, or has text or icon. So you start with when you create a new button here, it is in the no text or icon state. And then when you call with text or with icon, it doesn't care about the input, but it returns a button that has text or icon. And then toHTML needs a button that has text or icon and returns HTML message. So because with text and with icon don't have any constraints on the input, you can combine them. You can say with text and with icon, but you at least need one of them. Otherwise, toHTML will not work. And this works great. You get the same kind of compiler error as before, but here the problem is that we lost the constraints on the onClick and disabled that we had before. So what we need to do is to extend those constraints. And that's where the third part, extensible records, come in. So extensible records are something in the type system from Elm, where you have records, but you don't know all of the fields that it has, but you know some of them. So here, increment x, for instance, has a record a. We don't know all of the fields, but we at least know that it has the x field that is of type int, and it returns the same one, a with x of int. What is not possible is to transform the record. So you can't say, you can't create a function that takes a with x of int and returns an a of not x with int, because there's no way to create an implementation that creates the return record based on the input record. But thankfully, that is not a problem for phantom types, because we do not need to provide an implementation. So you can have a with something that takes a button with a with x of int and returns a button with a with not x of int. That is not a problem at all, as long as you create, you call the constructor again, which kind of resets the constraints. So what you can do with this mechanism is these four things. You can remove a field, so having a button from with a record a with x to a button of a. You can add a field. You can change the type of a field, so x of type y to x of type z, or you can reset the record to reset the type variable to a record or anything, really. So those are four basic capabilities. And with this, I present to you the Extensible Records Phantom Builder pattern. So this example here has both constraints, both of the constraints that we talked about before. So how does it work? So we start with a new button that needs interactivity. With disabled, takes a button that needs interactivity and removes the need for interactivity and says it has interactivity. So when you call with disabled and then with onClick, or the other way around, that's going to create a compiler error, because the second one will not have needs interactivity anymore. It will only have has interactivity. So we still have the same constraints as for the first example. And then with text, same thing with icon. Does not have any constraints on the input, but it returns a button that has text or icon. So it just adds that field. If it wasn't already there, if it was already there, it doesn't do anything. And then 2HTML takes a button that has interactivity and has text or icon. So you need to have called at least once with text or with icon, and at least once with disabled or with onClick. And this is maybe a bit for both, but we didn't create any custom types. We didn't create any of those types with the never at the end. And yeah. So there's a lot of basic constraints that we can create with this. So you can require a function to always be called. So we did that with text, for instance. We can forbid calling the same function twice. We did so with disabled. And then you can do things dependent on whether something else was called. You can, if something else was called, you can require a function to always be called. You can enable a function to be called, or you can prevent another function from being called. Some of those we showed before. And this is super extensible, really very much configurable. You can do a lot of constraints like this. That if you use other kinds of patterns, you would need to. It would be pretty convoluted. This is on its own already very malleable. You should probably use it with other patterns, like moving arguments to the mandatory, make them mandatory by moving them to the new arguments, stuff like that. It's just one tool in your tool belt. All of these checks have no runtime cost because they're only handled by the compiler. So once it gets compiled, you don't have any of the phantom build pattern anymore. And the thing that I like most is that in the usage, it just looks like a regular build pattern. You can't tell that it uses a phantom build pattern under the hood. You only know it uses a build pattern. And then you can even change the constraints without changing how you use the code. So if we, for instance, if we made new mandatory with by changing the arguments to, if we made the text mandatory by changing the arguments to new, then we would need to change everywhere we use the new function. With this, you don't need to. It's still the same. Unless you get somewhere where the constraints were violated. And it does have, unfortunately, some drawbacks because just like any pattern, it has its uses, it has its places where it's not very useful or not appropriate. So let's go through some of them. You cannot put multiple of these schemas in a list. So sometimes. So button.new is not of the same type as button.new with disabled. So you cannot put them into a single list, which was a problem for me in Elm Review because Elm Review uses the phantom build pattern. And what you end up doing usually is transform it to the final version so that they are the same type. In this case, they are both HTML message. Conditionals, if you want to apply a function that changes the constraints, and you want to apply it conditionally, that can become a problem with regards to the type system, because often what you would do with the build pattern is to say, oh, I don't want to apply the function, I use identity, and that these two do not match, they're not compatible. So what you usually do is something like this. If it's disabled, call with disabled, otherwise with onClick, call with onClick, and these two are of the same type. There are other ways around it, but this is what I would recommend. if possible. And then this is an issue for package authors, not so much for applications maintainers. All constraint changes are breaking changes, so you have to be careful in your design and think about it, because otherwise, when you release a new version of your package, it will be a major version. And the API needs to be airtight, in the sense that if you are not careful, something that you made impossible, like a button without text, can be made possible again if it's used in combination with some other builder function where we're not careful enough. So again, mostly for package authors, you need to think about it quite extensively. And then testing. You cannot test these constraints using Elm test, because if you want to make sure that something is not possible, then the test won't compile. So what you do is, or what I did for Elm Review, is to have a list of source files that I compiled individually, and I basically snapshot test them to make sure that they pass or they fail with the error that I expected. All right. I hope you liked this. I hope you found it interesting. Now go make awesome things, please. Thank you.
Awesome, Jeremy. Thank you, Jeroen. Thank you, Jeroen. Okay. So, shall we open the floor for any questions for Jeroen?
I have a question. If I'm an application developer consuming a package that's using the Phantom Builder pattern and I'm not aware of it, how user-friendly or unfriendly are the error messages if I were to create an impossible state in at compile time?
Do I have an example somewhere? I found them to be pretty good, the error messages. So this is basically what you would have, but instead you would have a record. So you would have something like that says, I require a button that has text or icon, but I got a button that needs does not have that field. One thing that is pretty nice actually with this pattern is that you can kind of customize the error messages, because you can give names to the fields. Mm-hmm. So you can make them almost as nice as you want. You do have some limitations, but compared to other banners or you can customize the error message, which is pretty new, I find.
Cool.
But that doesn't. Is it different with the extensible record version?
Yes, not very much, but maybe let me.
I don't know if you have.
I can try and grab something.
Because I was surprised to think that the extensible records version in the code seems almost more readable. And I don't know if it's exactly the same in there. If the constraints word, for example, appears in the error message.
Mm-hmm. So let me just. Yeah, I'll grab something else. Please keep questions coming.
I have a question, or it's more of a comment. Mm-hmm. I just wanted to say that I found this version with visuals easier to follow than the Elm Radio version.
Surprising.
It's a great compliment to it. Yes.
All right. Here's an example. Here I created an Elm review rule which uses this pattern, and I created a rule without any visitors, and I need one. So you're not gonna see it. Here we go. So what I did was I commented this visitor, which means I have no visitor, and the compiler says I have a module rule without anything, and I needed a module rule with has at least one visitor. So what you can do is to say, to rename this to needs with text, if you want to be very clear. In that case, I know what I need to do. I need to call with text, which in this case does not work because there are plenty of ways to add visitors. But if you can be specific, you can help out the user very much.
Yeah, I like that, where it describes what the next expected state is to be.
Yeah. So you might have noticed that this is pretty complex, and it requires some learning to use it. So I do plan on writing some extensive blog posts about it at some point. If you do want it, let me know. That will motivate me to write them.
But it was for me, it was perfect to complete the podcast episode. So I don't know if it's the same in the other direction.
Well, yeah, I really hope to go through more examples on how to design things, like when would you use constraints this way? What are the pitfalls of doing it this way? What do you need to think about? As I said, it needs to be airtight, so it is actually pretty complex to do it right.
Okay, great. That seems like a great point to leave it. So please join me once more in thanking Jeroen for his talk. Thank you very much, Jeroen.